For a relatively long time in human history, travel to neighboring planets has only become possible recently. Numerous discoveries have led to many questions. Why do we live on only one of the 8 planets in our solar system? Are our adaptive capabilities limited? What would happen to a human on the lunar surface? Considering our neighboring planets, it becomes interesting to wonder if there's intelligent life, organic life, animals, internet access, and so on their surfaces. Today, we'll imagine what would happen to a human who finds themselves in the wrong place at the wrong time. On a different planet, it's no secret that the human body, without a spacesuit, is incapable of surviving in the harsh environment of space. It would be extremely cold or extremely hot, and an unprotected head would essentially explode due to the pressure difference. Unfortunately, we are not familiar with anyone who has visited the surface of Jupiter or Mars in just slippers, but no one prevents us from using scientific facts. Let's skip the effects of open space and descend to the surface of our nearest natural satellite. So, you're standing on the surface of the moon. A small spoiler: boiling an egg will take longer than your lifespan there. The low mass of the celestial body doesn't allow its atmosphere, which is 6 times thinner than Earth's, to hold oxygen molecules, of which there are none due to the absence of plants. However, you won't die of suffocation. The lack of atmosphere creates near-vacuum conditions. A person can survive in a vacuum for about 90 seconds. They won't explode and will remain conscious for about 10 seconds. In 1965, NASA recorded an incident where an astronaut was exposed to vacuum conditions due to a damaged spacesuit for 15 seconds. The astronaut remained conscious, and the last thing they remembered was air leaking and saliva boiling on their tongue. The boiling of saliva, however, doesn't actually raise the temperature. It lowers it due to evaporation and the inability to thermoregulate. Incidentally, the astronaut survived. If you remember Schwarzenegger's reaction on Mars in a movie, it's an absolutely realistic depiction of the human body's reaction in a vacuum. Holding your breath will not cause your lungs to explode instantly. Let's move on. As you might guess, one thing leads to another. The temperature conditions on the moon are merciless for us, again due to the lack of atmosphere. The first 13 days, one can turn into charcoal on a fast 107 degrees Celsius fire, and the following 13 nights, the temperature will drop to minus 150 degrees Celsius. In the darkest hours, the temperature in deep polar craters sometimes approaches absolute zero, around minus 250 degrees Celsius. During a lunar eclipse, when the moon moves into the Earth's shadow, in just 90 minutes, the surface temperature can drop by 300 degrees Celsius. However, a person wouldn't have time to fully freeze or roast. Of course, all the factors mentioned above would act simultaneously, but the strongest adverse factor would be solar radiation, from which a fur coat or sunscreen won't protect you. The level of solar radiation has long called into question the possibility of human landings on the moon. Solar radiation has a lethal effect far exceeding anything reproducible on Earth. Damage to internal organs, bone fracturing, and tissue death, combined with the factors mentioned above, would cause considerable suffering. Of course, things might not be exactly like that, but so far, there haven't been any volunteers to test the moon's hospitality. We are not eternal, at least not in our solar system. And there are many reasons for this, from viral diseases to the extinction of our sun. Recently, the Global Challenges Foundation released a report on the dangers threatening the entire human race. Climate change, for example, is a significant threat. The proportion of carbon in the Earth's atmosphere is currently the highest ever recorded. This is due to technological and industrial development, population growth, and consequently, increased consumption. If the current level of emissions into the atmosphere persists, there's a probability of a 6 degrees Celsius rise in the Earth's average temperature, resulting in the melting of polar ice and the flooding of the most densely populated regions of Europe and America. Nuclear catastrophe is another significant threat. In 2014, there were over 90,000 nuclear warheads ready for launch worldwide, the majority of them in the USA and Russia. In 1979, specialists from the U.S. Office of Technology Assessment estimated that, in the event of a nuclear exchange between the USA and the USSR, up to 40% of the population would die immediately, and several million more would die within a few years from radiation, burns, and other related factors. Another serious danger is nuclear winter. According to rough calculations, a nuclear war between the USA and Russia would lead to an 8 degrees Celsius drop in temperature and make food production impossible for 4 to 5 years. Even a smaller nuclear exchange between India and Pakistan would lead to a 1.25 degrees Celsius drop in Earth's temperature and famine for a billion people. Pandemics have decimated human populations throughout history. Nearly 100 years ago, the Spanish flu pandemic reduced the Earth's population by 5%, but that was before modern medicine with antibiotics and bioengineering. The last relatively large influenza pandemic occurred in 2010. However, the authors of the report note that the risk of death from viral diseases remains high, especially in regions with poorly developed medicine, such as Africa, where a recent Ebola epidemic claimed over 10,000 lives. Predicting when the next pandemic will occur and its mortality rate is quite difficult. For example, the UK's National Risk Register estimates the probability of the death of more than 1% of the country's population in the next 5 years to be between January 2nd and January 20th. Natural catastrophes unrelated to humans, such as a large volcanic eruption or an asteroid collision, pose another risk. 70,000 years ago, the eruption of the supervolcano Toba in Indonesia, blocking access to sunlight, lowered the Earth's temperature by 35 degrees Celsius, an effect similar to that of a nuclear war. Predicting the eruption of a similar supervolcano is practically impossible. It is only known that they show activity every 30 to 50,000 years. An asteroid collision approximately 66 million years ago may have led to the extinction of the dinosaurs. Currently, the fall of an object 1.5 kilometers in diameter could lead to cooling, a reduction in habitable land, and a decrease in the population by about 10%, according to calculations by the U.S. National Research Council. If an asteroid about 10 kilometers in diameter were to hit the Earth, it could cause the extinction of humanity. Man-made epidemics also pose a threat. There is scientific research showing the possibility of artificially creating the H5N1 virus. In 2001, a vaccine-resistant form of mousepox was accidentally created in Australia. Theoretically, such a virus could fall into the hands of terrorists. Legal theorist Richard Posner believes that by obtaining the virus, criminals could provoke an epidemic by spraying it over a large city. Research laboratories working on the creation of dangerous pathogens to combat diseases also represent a source of risk. Have you ever wondered what would happen if the Earth stopped rotating around its axis? Humanity would face devastating changes, especially if the Earth stopped rotating suddenly. Before disappearing, we wouldn't even have time to understand what happened. The instantaneous effect would be significant because the rotational speed of our planet is 1,670 kilometers per hour. Upon stopping, everything not embedded in the bedrock, animals, people, trees, buildings, would simply be swept off the Earth's surface. In addition, the oceans, due to inertia, would continue to rotate, creating gigantic tsunamis that would engulf the few lucky survivors. The collision would also cause numerous earthquakes and volcanic eruptions. Day and night would transform. A day on the planet would last 365 days. On one half of the Earth, the sun would shine for almost half a year, resulting in unbearable heat, while the other half would experience a 6-month-long cold night, with only short periods of twilight between the winter night and summer day. Water and land would also be affected. Currently, centrifugal forces flatten the Earth at the poles and create a bulge at the equator. The planet's diameter at the equator is 43 kilometers larger than at the poles. Without rotation, the bulge would disappear, and the oceans would flow towards the poles, leaving a single giant continent and 2 ocean caps. East and west would also change. The sun currently rises in the east and sets in the west due to the Earth's rotation from east to west. If the planet stopped rotating, sunrise and sunset would be determined only by the Earth's revolution around the sun. Sunrise would be in the west and sunset in the east. Most animals and plants would not be able to adapt to the drastically changed conditions. Some species would gain an advantage, for example, Antarctic dwellers accustomed to the 6-month night. In the process of forming a new geography, Antarctica, Greenland, Canada, Siberia, all of Europe, part of China, and half of New Zealand would go underwater. Along the equator, up to 30 degrees north and south latitude, plains and mountain ranges would appear. Climate and particle distribution would change, and winds would begin to blow towards the poles instead of parallel to the equator as they do now. This would alter climate and ocean currents, leading to global restructuring, primarily in marine ecosystems. Exposure to high-energy cosmic particles would be lethal to humans and other living beings. People would have to move underground to grow plants and raise livestock. For walks on the surface, they would need to wear spacesuits or protective clothing. Will the Earth actually slow down its rotation in the future? The Earth is indeed gradually slowing its rotation due to the tidal forces between the planet and the Moon. These forces arise because the parts of the Earth closer to the Moon are attracted to it more strongly than those farther away. Every 100 years, a day lengthens by 1.5 to 2 milliseconds. In 140 million years, there will be 25 hours in a day. However, humanity will not live to see the complete stop of the Earth, as in about 5 billion years, the Sun will turn into a red giant, increase in size, and engulf our planet. When people hear the phrase quantum teleportation, the key word for them is teleportation, i.e., instantaneous movement of an object from one point to another. This statement is mostly correct, except for one thing. Not any objects can be teleported using this method. Only their state is transferred. As a result, something with the same properties as the original object can appear in any location. A quantum is a particle millions of times smaller than an atom, and such formations permeate everything around us, including humans. We are not just bones, muscles, and organ systems. A human consists of sensations, feelings, and various wave fluctuations, i.e., oscillations. Our quantum energy includes not only the intellectual vibrations of the brain, but also the collective consciousness of our 50 trillion cells. The organism is the foundation of nature at the level where matter becomes equivalent to energy. Initially, our body consists of quantum oscillations that are transformed into cells, organs, thoughts, and emotions. The signals that our quantum body sends us are sometimes perceived as intuition. At the quantum level, all parts of the human body, from atom to organ, from feeling to thought, are informationally united. If we are happy, this chemical cocktail travels through the body and shares this feeling with the cells. The same thing happens when sadness arrives. Diametrically opposite compounds literally poison every molecule of the human body, suppressing the immune system. Therefore, we are totally controlled by quantum oscillations. Thus, human thought can be transmitted from one object to another at any distance, as soon as scientists understand the nature of this process and learn to control it. In the future, it is planned to create global quantum commutators, all participants of which will be able to instantly exchange thoughts. It is also possible to design computers that could explode our usual ideas about cyberspace. The information volume and speed of information transmission of these unthinkable machines will be tens of orders of magnitude higher than those currently existing, and quantum viruses will become a programmer's nightmare. After teleportation, they will be able to function outside the computer network. The information unit of such a device will be a qubit. Currently, cyber information is encoded using various sequences of values of 1 and 0, but a quantum bit will include not classical discrete values, but their superposition, characterized by the superposition of 1 on 0, i.e., a unit in a state of 0 and vice versa. Although this is impossible from the point of view of orthodox informatics, the most significant goal of quantum teleportation, its pinnacle, is unfortunately still unattainable even in the foreseeable future. Literally transferring a human being via telegraphy. So far, such experiments have been conducted only at the photon level. This process is possible if the quantum telegrapher has the entire set of atoms, essentially a complete and detailed description of a person. Then, using a complex mechanism for transforming states, it's possible to clone a person at any given point. But don't imagine a nightmarish invasion of clones. This would not teleport personality. There would still be only one person, since the sample taken would self-destruct immediately after teleportation. But future generations should bear in mind that one single mistake could turn what was once a brother or uncle into a chaotic and meaningless collection of atoms. Intelligent civilizations have had enough time to contact each other, assuming that extraterrestrials exist, so why can't we detect them? It took billions of years for our Earth to become unique. Many events shaped it into what we know it to be, and perhaps a similar planet doesn't exist in our dimension. But this doesn't mean that there's no life anywhere else. It most likely exists, but in a different form, where similar organisms exist. We may not have encountered them because they don't exist, or there are so few of them. And they are so far away that contact is extremely unlikely. The most important factor that makes Earth hospitable is stable climatic conditions. If not for our precise position relative to the Sun and the Moon, the planet would be too hot or too cold, with insufficient oxygen and too unstable conditions to support life beyond bacteria. Although we have found many Earth-like planets, scientists are still confident that the chances of life existing on these worlds are extremely low. According to the Great Filter Theory, extraterrestrial life does indeed exist, but intelligent life is unable to advance technologically far enough to invent long-range space communication or space travel. Although our modern spacecraft, satellites, and radio speak of the fact that we are close to the point of no return, we might be inevitably facing a barrier or catastrophe that will either destroy us or lead to technological degradation. We know that catastrophic natural disasters periodically visit Earth, so it is quite possible that these same events destroy worlds everywhere, sending intelligent life back to the Stone Age before technology can adequately develop. Or maybe we will destroy ourselves in a nuclear war. Whatever this filter is, we have only bad news. Not only will we not be able to communicate with other cosmonauts, but we will probably die. However, there is a bright side to this theory. Some believe that we are the first to pass through this filter, and therefore will most likely become the dominant race in space. According to the Transcension hypothesis by John Smart, intelligent extraterrestrial life once existed in our universe but became so advanced that it moved on to better places. To be more precise, aliens developed to the point where they stopped looking at outer space and concentrated on inner space. This concept can be compared to miniaturization that we observe in computers. Initially, they were huge technologies filling entire rooms, but then they became smaller while simultaneously increasing in complexity and power. For supporters of the Transcension hypothesis, intelligent life develops in much the same way, constantly working on denser and more efficient use of space-time, energy, and matter. Eventually, we will live and work at smaller scales until we become so small that we create and settle in a black hole. According to Smart and others, black holes are the ultimate destination. They will allow for ideal calculations and learning, time travel, energy extraction, and other things. Civilizations that do not achieve this are doomed. Recently, many scientists have been leaning towards the idea that all galaxies, including our surroundings, are most likely a program created by more intelligent beings. Let's imagine this picture. We are a prototype of a super technological experiment by intelligent beings. For example, for these more intelligent beings, time moves quite differently. If billions of years pass for us, it's only a few seconds for them. Perhaps they are billions of times larger than you and me and took several drops of a supernatural chemical element, and in this element, you and I appeared. For them, only a few seconds have passed by our standards, while for us, there is a whole chain of evolution. Mars, Earth's closest neighbor, is logically the focus of increased attention from the scientific community. Relatively few probes have landed on its rusty surface, but far more than on other planets in the solar system. Today we will talk about the Phoenix lander, which spent only half a year on Mars, but its contribution to the study of this celestial body is quite significant. Let's start with the name. Why does the probe have such a telling name? Did the apparatus, like the mythical bird, once rise from the ashes? The fact is that in 1999, a mission whose task was to study the polar regions of Mars failed miserably. When another apparatus, Mars Polar Lander, was constructed, it ironically inherited the shortcomings of its predecessor and was also sent to the scrap heap. But later it was retrieved from storage, and a new probe was created based on the old one. Thus, the interplanetary station was reborn. Therefore, the name of the Martian probe Phoenix is quite justified. The fact that the probe was not built from scratch resulted in its relatively low cost of $420 million. What new and unusual things did the probe see upon landing on Mars? Interplanetary travel is a complex task, so missions are often accompanied by unforeseen difficulties. Phoenix was no exception. The launch was delayed due to weather conditions. The Delta II launch vehicle launched 3 days later, on August 4, 2007. The flight went without complications, and on May 25, 2008, the probe landed on Mars, becoming the sixth probe to land on its surface. During landing, Phoenix used parachutes to slow down, as well as deployed engines. Despite this, it entered the planet's atmosphere at a breakneck speed, more than 5 kilometers per second. Despite everything, the landing occurred in the planned area, at the North Pole of Mars. The course was set so precisely that it did not require correction during the flight. The moment of landing was filmed by an orbiting satellite. This unique image instantly went around the world. Unfortunately, the landing was the only part of the mission that went without a hitch. Otherwise, Phoenix was accompanied by a series of mishaps. Immediately after landing, the probe turned off, but after a while, communication was restored. It turned out that Phoenix spent several hours deploying its batteries. In the first session, the probe sent an informative image to Earth, a rocky plain covered with frost. The probe's task was to clarify what the climate in the Martian Arctic is like, whether the polar regions of the red planet are suitable for life, and to monitor the melting process of the ice caps. Did the probe achieve its goals? In general, yes, and it even managed to surprise many. But let's get back to the problems. The second problem, which followed immediately after the resumption of communication, was the inability to release the manipulator, the probe's robotic arm. After landing, Phoenix stopped receiving commands from Earth and, accordingly, could not release the manipulator for a long time. Finally, on May 30th, with the help of the Mars Reconnaissance Orbiter, the probe managed to do this, and it began to test the module. Phoenix was equipped with a large amount of useful equipment: an optical system, several microscopes, an advanced spectrometer, and a weather station. However, during routine testing, a short circuit occurred in one of the circuits of the gas analyzer. The gas analyzer was a key instrument on board Phoenix, and the module consisted of several furnaces in which the samples were heated to 1,000 degrees Celsius. From the resulting gases, the equipment had to isolate organic substances necessary for the construction of life. But when it came to taking samples, Phoenix's furnace refused to accept the lumps of Martian soil, considering them too large. For several hours, the probe fiddled with the manipulator over the furnace filter until it managed to fill the container. Did Phoenix find life on Mars as we understand it? No. The probe landed between 65 and 75 degrees north latitude, right in the 10-kilometer-wide Heimdal Crater. Why was this location chosen? The polar region is the least explored area on Mars. NASA published a map where purple indicates areas with the highest amount of hydrogen, the main element of water ice. It's no surprise that in this bleak desert, where precipitation was last recorded probably millions of years ago, Phoenix dug a 5-centimeter deep trench and discovered sublimated ice under the ground. This was one of the main findings of the mission. In addition, the probe managed to find magnesium, chlorine, potassium, and sodium and determine the acidity of the regolith. It corresponds to the Earth's indicators of weakly alkaline soils. In general, the soil in the Martian Arctic resembles the composition of the soils of the dry Antarctic valleys. But on August 1, 2008, an even more extraordinary event occurred. NASA publicly announced that the Phoenix probe had found water in Martian soil samples. This was a real breakthrough. William Boynton, a researcher from the University of Arizona, noted that for the first time, Martian water could be touched and seen, rather than just assumed to be present. However, the following discovery dampened the enthusiasm of scientists. Perchlorates, salts, and monobasic acids toxic to terrestrial organisms were found in Martian soil. What does this fact say? That organisms of the terrestrial type are unlikely to have ever lived on Mars, but it is not excluded that the perchlorates are part of rocket fuel and were brought to the planet by the probe itself. Along with research, the probe transmitted panoramas of Martian daytime landscapes. At night, Phoenix peacefully slept as it worked on solar energy. For example, here's a photo of the area under the probe's chassis. Presumably, ice is visible in the picture. A projected panorama of Mars also reached Earth, a rocky landscape stretching to the horizon. By the way, at first, the probe used flash memory for data storage, but after a malfunction when Phoenix sent one image 45,000 times in a row, the probe began sending information immediately after receiving it. Phoenix also investigated Martian regolith, examined in such detail for the first time. But the most unique event during the mission was the picture of the sun rising over the dead Martian plain. But everything comes to an end. The mission ended on November 2, 2008, when Earth stopped receiving signals from Phoenix. A dust storm recorded on November 11th finally put the probe out of action. In 2010, a reconnaissance satellite sent a photo of the probe in a deplorable state. It did not survive the Martian winter. One of its solar panels broke under the weight of the icy crust. It became clear that the mission could not be resumed. But on Mars, not only the wreckage of Phoenix remained, it was also equipped with a digital collection of science fiction. The development, flight, landing, and death of Phoenix resemble a science fiction thriller. Considering that the presence of Earth probes on another planet just 150 years ago was considered an absolute miracle, it is unknown whether apple trees will bloom on Mars, but now we know for sure that there is water there to water them. At this stage, humanity is like mischievous children who suddenly discover the consequences of their mischief. We have poisoned the Earth's atmosphere and water bodies, dried up and reversed many rivers, built factories on millions of square kilometers of fertile soil, exterminated entire species of animals and birds, and cut down forests. Now, having come to our senses, we are looking for a new home. Why? To treat it the same way as Earth? If we leave aside the pathos, the situation is indeed rather bleak. Therefore, we will have to relocate, sooner or later. The reasons may not only be climate change or resource scarcity. There are also external threats, such as an asteroid attack or the death of the sun. Be that as it may, scientists are actively searching for planets where Earthlings can easily relocate. Of course, the greatest temptation is to find a ready-made solution, some exoplanet in the immediate vicinity with ideal conditions for life. But the active search of the Kepler telescope demonstrates that in the near future, this is a utopia. Therefore, the only acceptable way out remains terraforming one of the planets of the solar system. For example, Mars. What does this term mean? Briefly, terraforming is a long and systematic process of transforming a dead celestial body into a habitable one. The red planet, often called a place of past life, can become a testing ground for the future. But for this, titanic efforts will have to be made. Colonization and terraforming of Mars is a real technological breakthrough, but how can it be achieved? The red planet is similar to Earth, but it still has many obstacles to achieving this global task. Let's set aside ethical questions such as the potential displacement of local life forms and their replacement with terrestrial ones, and turn to more specific problems. The person who sets foot on Mars faces specific tasks: not to suffocate, not to freeze, and not to die from cosmic radiation. That is why the first colonists must build reliable bunkers equipped with a life support system and not try to leave them without spacesuits. But we'll return to future settlers later. For now, let's consider what prevents us from turning Mars into a second Earth. The extremely thin atmosphere is too rarefied, making the planet currently unsuitable for habitation. For example, everyone knows that water is the basis of life. So, if you pour a glass of water on present-day Mars, part of it will evaporate, and the other part will freeze. How to create conditions for retaining liquid on the planet's surface? You need to make the atmosphere thicker and denser. This will also help to make the climate warmer. It is known that the Martian polar caps contain some carbon dioxide, but it is extremely little for comprehensive transformations. So what are the theorists of science going to undertake? It turns out that CO2 is also contained in the regolith, Martian soil, and its sublimation would help raise the planet's temperature and make the atmosphere denser. In this case, the surface pressure would approach that at the top of Everest, and colonists would not have to wear bulky spacesuits. Oxygen masks would be sufficient, and even then not always. Alternative methods for modernizing the Martian atmosphere, temperature, and pressure are even more original. Some astrophysicists propose to crash several ammonia-rich planetoids or asteroids into Mars. As a result of the impact, a considerable amount of energy will be released, turning into a heat source. The released gas will replenish the alien atmosphere with nitrogen. Remember that the mixture we breathe now consists of 78% nitrogen. To heat the red planet, besides the methods mentioned, even more original options are proposed, such as using a solar sail and huge mirrors. They are planned to be placed in Mars orbit to increase the planet's insolation and heat the surface. This way, you can kill two birds with one stone. Release frozen carbon dioxide from the Martian polar caps. Consequently, after some time, in conditions of a denser atmosphere, increased pressure, and temperature on the red planet, some plants could survive. The biosphere, releasing oxygen and absorbing carbon dioxide, would gradually transform Mars into a habitable world. A nuclear explosion above the planet's surface, as mentioned by Elon Musk, will definitely not help with terraforming. Scientists claim that even if you detonate all of Earth's nuclear potential, the desired result will not be achieved. The energy obtained as a result will be equal to the amount of solar energy absorbed by Mars in an hour. Weak gravity and radiation danger are the most difficult obstacles to overcome. Mars' gravity is 38% of Earth's, which will certainly affect future colonists and will not allow even artificially generated atmosphere to be retained around the planet for a long time. To counteract the evaporation of atmospheric layers, scientists from the MAVEN project, led by Michael Chaffin, propose building factories on Mars to produce super greenhouse gases. These substances will not destroy the planet's thin ozone layer and will not pose a toxic threat to potential colonists, but over time, the accumulation of gases will contribute to the densification of the atmosphere and warming of the climate. Further, plants would complete the terraforming process and, over thousands of years, turn Mars into a flourishing garden. As for the radiation threat, it is quite real, despite the fact that the planet is farther from the Sun than Earth. Again, the insignificant atmospheric layer and the absence of a magnetosphere prevent the celestial body from being shielded from harsh radiation. Modern technologies are unfortunately powerless in this regard. Science does not yet have a strategy for building a magnetic field on a planetary scale. From the foregoing, we can conclude that effective CO2 sublimation is the key to terraforming, as the process is capable of optimizing several of the most important factors of planetary habitability. But with the generation of the greenhouse effect, the main thing is not to overdo it. Otherwise, the result may be not Earth, but Venus, with its monstrous pressure and temperature, ideal for melting lead. The final question is, where is the most convenient place to locate the Martian colony? First, we will have to learn to live on the planet in its current state. The specific location has not yet been chosen, but in 2020, it is planned to send a reconnaissance spacecraft to the Red Planet, which will conduct round-the-clock broadcasting from the Martian surface. The data obtained will be used in the design of manned missions. Considering the totality of theories and facts, it is important to understand that Venus, Mars, and Earth are essentially equivalent stony masses whose climates can potentially be changed in the future, and thus, these celestial bodies can be terraformed. Unfortunately, so far this can only be done on paper. In reality, everything is much more complicated. Consider, perhaps you have unique ways of terraforming Mars or extraordinary ideas for its colonization. Don't hold back your imagination, because epical discoveries always happen by chance. Do you want to know about a distant intermediate base between the solar system and deep space? Do you want to look at an alien world, many phenomena of which defy rational explanation and understanding? Then prepare for a long journey, as this planet is millions of kilometers from Earth. Welcome to the amazing Triton, the most famous satellite of Neptune. Due to its considerable distance, Triton has been studied by very few probes in the entire history of cosmonautics. More precisely, only Voyager 2 once flew past this small planet. This happened in 1989 as part of a transit journey past Neptune, Triton's parent planet. Here is the first photo of Triton taken by the Voyager 2 probe. The image is unique because before it, Earth had not received anything like it, especially from such a distant location. How unreachable and cold Triton is. Despite the short rendezvous, Voyager 2 discovered a number of unusual phenomena on this celestial body, for which modern science does not yet have a convincing explanation. At first glance at the numerous photos, it became clear that Triton is one of the few geologically active objects in the outer solar system, and its surface is relatively young, not exceeding 100 million years old. Triton rotates in the opposite direction. It occupies 7th place by size among the satellites of the relatively near surroundings. It is assumed that this celestial body is an alien from the Kuiper Belt, later captured by Neptune. One unexpected discovery that Voyager 2 made was the presence of a rarefied atmosphere around Triton. The cloud layer above the satellite is approximately 100 kilometers. Measurements showed that the atmosphere consists mainly of nitrogen, with small inclusions of methane and carbon monoxide. Surprisingly, the pressure, which was about 19 microbars at the time of Voyager 2's measurement, increased significantly according to data from 2010 and now varies from 40 to 65 microbars. The reason for this phenomenon remains unexplained. What can be said about Triton's surface? It is quite unusual. To understand this, Voyager 2's short visit was enough. The planet has 12 types of relief, from chains of craters and strange furrows to vast plains and cryovolcanoes. In the presented image, dark spots are visible, the consequences of their eruptions. Near the equator, the probe discovered an interesting object, similar in outline and structure to a frozen lake about a kilometer deep. A small impact crater is visible on its surface. Such formations may indicate that liquid existed on Triton for centuries. Now, the celestial body resembles a huge, regularly shaped piece of ice with a diameter of 2,706 kilometers. The surface temperature reaches incredible -235 degrees Celsius, making it the coldest celestial body in the solar system. It's so frosty that even nitrogen falls on the slopes and valleys of the mysterious satellite in the form of frost and snow. During Voyager 2's visit, its polar cap was truly enormous, covering a significant part of the southern hemisphere. According to the data obtained, it consists of a mixture of nitrogen ice, methane, and carbon monoxide. Another important question is the number of craters. On the observed hemisphere, Voyager 2 found only 179 craters, while on Miranda, whose size is 3% of Triton's, 835 were recorded. This fact, as mentioned earlier, indicates significant geological activity of Neptune's satellite. The Interplanetary Station also discovered something unusual and mystical on Triton, a surface unlike anything else in the solar system, the cantaloupe terrain. What caused the formation of such a strange relief? This area is considered the oldest on Triton. The area is densely covered with huge structures up to 50 kilometers in diameter with fairly smooth and high edges. Surprisingly, the craters are characterized by noticeable curvature, unlike the clear forms of standard craters. There are many theories about the origin of this relief, and one of them claims that its origin is connected with very powerful cryovolcanic ejections that periodically flooded this area, melting the ice crust. Later, the substance solidified and cracked. Cryovolcanoes are unusual phenomena from the point of view of orthodox science. Their appearance is possible only in conditions of extremely low temperatures when, instead of molten rocks, mountains erupt water, nitrogen, and other substances, both in liquid and gaseous states. In the Voyager 2 image, one such eruption is shown, with an interval of 45 minutes. In the blurry image, you can distinguish a plume of particles rising 8 kilometers and drifting in the wind at a distance of about 150 kilometers. But where is the huge Neptune, which should reign supreme in the skies of Triton? The probe photographed the blue planet. You can clearly see how the gas giant looks from the surface of the satellite. Even the global hurricane known as the Great Dark Spot is visible on it. Voyager 2 managed to do the impossible. The images sent allowed scientists to create a relatively detailed topographic map of the distant satellite's terrain. The following image, with a resolution of 10 kilometers, greatly helped to achieve this goal. But everything comes to an end. The fruitful mission of the probe inevitably came to an end, casting a farewell look at Triton. The probe literally flew away into the distance and night. If you look impartially at this picture, you might think that this is not Neptune's moon, but our own. Voyager 2 carried a golden record with recordings of human speech, the roar of volcanoes, the whisper of ocean waves, the voices of birds and animals, as well as recordings of famous musical excerpts. But on Triton, apparently, there is no one to listen to these magical sounds, although astronomers suggest the presence of a subglacial ocean on the satellite, similar to the one that probably splashes under the crust of Europa. According to assumptions, the temperature in it does not exceed -97 degrees Celsius, and the ocean consists of water and nitrogen. However, it is unlikely that life, as we understand it, could have originated in such a harsh body of water. Nevertheless, Voyager 2 continues its journey through the inky blackness of space, and we should think about the following. If Earth doesn't organize a mission to Triton in the near future, then over time, due to Neptune's tidal influence, the satellite will gradually approach the planet, reaching the Roche limit and inevitably crashing into its gaseous neighbor. The Moon will be torn apart, and a ring system several orders of magnitude larger than Saturn's will appear around Neptune. In this case, Voyager 2 will remain the first and only probe to visit the outskirts of the solar system. Have you ever seen a nuclear explosion with your own eyes? Fortunately, only a few have witnessed it. But photos and videos of the mushroom cloud on the horizon have long become public domain. But with all the grandiosity of the consequences, the explosion of a neutron bomb is nothing compared to the death of giant stars. Even if you detonate all the arsenal at our disposal, it will be like a weak candle flame next to a super powerful spotlight. Why are we talking about this? Because recently, one such object, relatively close to Earth, most likely exploded or is about to do so soon. Where did such conclusions come from, and what threatens our planet in connection with this? Let's try to answer all the questions sequentially. First, let's characterize the star itself, whose life is steadily approaching its end. We